Hey guys, I'm Chili. Welcome back to Intermediate C++ Tutorial 25. Today we're talking about function pointers and about functional. Now, in Tutorial 24, I started things off by introducing you to the idea of what if we wanted to switch on a string, and then I showed you the map that allowed us to map from strings, for example, to some other data type like an int or a vec2, and that's cool, but that doesn't solve the original problem of switching on a string, because a switch executes some code based on the value that it was passed. So, how do we do that? Well, using a map, that means we're going to have to store as our value some executable code. Now, one way you might think of doing that, let's take a look at this code here, is you might think of storing them as a functor. So, function objects, and so your strings are going to map to function objects that you call when you look up the string. And that seems to be a good idea, but if we actually follow it through, we go std string mapping to what, right? Because each functor is a different data type, and you need a single data type that all of your elements in your unordered map are going to store as the value. So this is a problem. It can be fairly easily circumvented by using inheritance. So what you do is you create a base type that they all inherit from an abstract class. We'll call it case function. All right. And I think you can see how this is going to go, right? It's going to be virtual void operator, and it's going to be const, and we'll set equal to 0 because it's going to be an abstract class. These guys will inherit from that, and then each of your functors here are going to implement this pure virtual function override. We call this pattern, some people call it a functionoid, and it's just polymorphic functors, right? And now that we've got that, we can make our value in our unordered map, we can make it case function. Let's try that. See how that works. And now we want to actually add some cases to our switch, so we can go switch at 69. And we can set that equal to a new 69 functionoid. How's that going to work? Yeah, seems to work fine. No problem. Let's build it. Shit's the bed. Okay, well, why is that? Can you guess? A little bit of pop quiz for you. Problem is that this unordered map container is storing case function objects, right? And that's a problem for a number of reasons. First of all, we want to be able to store any kind of thing that inherits from case function. But if you put it as just a static object, it has to be a case function. So that's a problem. And it's also a double problem because you can't actually instantiate a case function. It has a pure virtual function, so it's an abstract class. It cannot exist in reality. So it's a double problem. Now, if you want to leverage polymorphism, say it after me, what do you need? You need pointers or references. So we want to store pointers to our functionoid objects. So what we do is we'll include memory, and we can make this thing store std unique pointer to a case function. And that means that the unique pointer can be pointing to a case function or any of its children. And then in here, we can use make unique to add cases to our switch. So here we add the functionoids to our switch map, and now let us actually switch on a string value. So we're going to switch on the string value 69. Now this is going to give us a pointer to a functionoid. So we want to call that. So first we have to dereference the pointer, and then we can call the operator on it. And this should do it. The syntax isn't the sexiest in the world, but you can see here, it works. So now we're switching on a string, and that allows us to execute some code based on whatever string we pass it. So yeah, this works and everything, but it's not my favorite. I don't really like the syntax here. It's a little clunky. And then you've got the whole unique pointer thing, and you're forced to put things on the heap, which you might not want to do. And I mean, you gotta have this base class or struct here, and then you've got to create a new struct every time you want to add another case, and it's just a pain in the ass. The definition of the cases is separated from where you actually add them to the switch. It's just a whole bunch of stuff that we don't really like. Luckily, there's a number of ways to skin this particular cat, and I'm going to go over many of them. Now, in C++, you can create something called a function pointer, which you might have guessed from the title of the video. And the idea is actually very similar to a pointer to data. Pointer to data stores the address of the data in memory, and pointer to the function stores the address to the first instruction in the function in memory, because functions are just a collection of instruction bytes in memory, and if you jump to the address of the first instruction, you will execute the function, essentially. So how do we declare a pointer to a function? What's the syntax? Well, int is the return type of the function that this pointer will point to. Star means pointer, give it a name, pfunc, and then you've also got to give the parameters, the types that are passed to it. And our pointer is going to point to functions that take an int. And there you go. That is how you declare a pointer to a function. So this pointer can point to any function as long as it takes an int and returns an int. And we've got two functions that do that up here. So if we go pfunc is equal to, and now when we want to set it to point to a function, all we do is we type the name of the function by itself. Should probably spell the variable name correctly, but yeah, there you go. And this might seem weird, but it's not that weird. When you think about arrays, an array without the square brackets, just the name by itself, evaluates to a pointer to the beginning of the array. And similarly, a function name without the function call parentheses evaluates to a pointer to the beginning of the function. So you can store that in your pointer, and then we can invoke that. So let's do it. So here I'm setting pfunc to point to double, and then I'm invoking that and printing out the result. Then I'm going to set it to point to triple and invoke that. And you should expect to see a 4 and a 6, and that's what you get. So now you've got a single pointer that can point to different functions, and you can invoke that and get the behavior of whatever function it is currently pointing to dynamically at runtime. So we can use this with our map here. So I got a couple functions here that do the same as we had before with our functionoids. And now I got to create an unordered map that maps to them. So what's the type? Again, returning void. It's a pointer to function, but we're just giving the type, not declaring a specific pointer. So we don't put a name in here, just a star. And then the values that it takes, it doesn't take any parameters. So we can just make this empty. And there you go. Now we're mapping from string to a pointer to a function that returns void and takes nothing. And then when we want to set up our mapping, we can just type the names of the functions in here, and that will map strings to our functions. And because this is returning a function pointer, to call a function pointer, like I've shown you, you just put the brackets after the function pointer and it will be called. So we got nicer syntax here. This looks simpler, less boilerplate to type in here, and we get the proper result. So this would seem to be a nicer fit for our switch. And you might even be asking, what's the point of functionoids anyways? And there are points of them. The ability to have the hierarchy of objects means you have more type safety. This unordered map can map to any function that matches this signature, even functions that have nothing to do with what we're trying to do. Whereas with a functionoid, you have more type safety. So functionoids have their place, but I don't really like them for this application here. I prefer function pointers. And that is how you use them. And while they are good, we still have the problem of having to declare a new function for every case that we want to add to our switch, and having the function declarations kind of separate from where we actually map the cases to the strings. So what I really want to be able to do, what I would love to be able to do here, is if I could just put a lambda function. If I could make a lambda function for each of my switch cases, something like this, and put my code in here, this would be great. No duplication, just the code and the string that's going to map to the code. Unfortunately, this doesn't work right. This is not really kosher because we have to give a single type for all of the values in this unordered map. But every Lambda function is its own separate type, so that's not going to fly. And you can't do some polymorphic functionoid stuff with Lambda functions that you can't inherit with Lambda functions. Doesn't make any sense. So I guess we're just stuck with not being able to use Lambda functions, which is what I would say if I were a big fat liar, because we can use Lambda functions. We just need a little bit of magic from the standard library called functional. And what functional gives us is it gives us a type called function, std function. And std function is a wrapper around callable things. So it wraps pretty much anything that is callable with parentheses. And it can bring them all under a single polymorphic interface. So let's use std function, and these std function objects are going to hold callables with a specific signature. You got to give them a signature. So you type the signature like this. It's like the function pointer syntax, only this type is a pointer to a function. So without the star, that is the actual type of the function, void, and takes no parameters. So this std function object is going to hold functions that return nothing and take nothing. Okay, so far so good. And then we can assign this lambda to that, and it will work. And let's do the same for 420, and that's going to look like this. And then if we try to run it, it works. And now we have our function definition in the same place where we map it. We don't need these guys anymore. And this is the way forward. Std function. These are different lambda functors, different types, but std function allows us to bring them into the same container because it basically adapts to any kind of callable type. And in fact, they don't have to both be lambdas. I can put one of these as 420, so I can assign a pointer to a normal standalone function here, and that will also work. It builds fine. And if I put in here 420, you will see that it works fine. So we can have all different kinds of functions, and they all go in the same container with std function. It's a beautiful thing. All right, to wrap things up, let's make a simple string switch class here. So we'll call it class string switch. And the private variables are going to be std unordered map from std string to std function void. And we'll just call this the map. All right. So we want a few functions up in here, and what they are going to be, let me think here. Well, we want one to set cases. And the way we're going to do this is we are going to return, I think we need one more angle brace here maybe. Yeah, that seems to be the ticket. All right. So we want to return a std function void reference. We want to return a reference to a function, and we're going to call this method case, and it is going to take a std string str. We'll just take it by value. I don't really care at this point. And all we're going to do is return map at string. And this will allow us to set functions for our cases. And then we're going to do void operator square braces. And we're going to take a std string. I could make it const. Doesn't really matter, but let's do that. And this one is not going to be modifying. This is what we're going to do when we want to switch on a string. So all we want to do when we switch on a string is we go map, add string, and we execute the function. And it's not liking it for some reason here. No operator matches. Oh, wait. I beg to differ. I definitely, it's const. And you don't like const. Okay, that's fine because there's actually something that I wanted to do here. So what we're going to do is we're going to go auto I is equal to, the problem there, by the way, in case you weren't understanding, was that the square braces is not a const member, so I can't call it inside of this function, which is const. But that's fine because it actually reminded me of something I wanted to do. So what we want to do is we want to map.find str. We want to find the string. Then if I is not equal to map.end, then we want to execute I, which is to say we want to do star I. No, we want to do I, because remember I points to an element which is a pair. I second is the value, and then we want to execute that. So if it is in the map, execute it. If it's not in the map, we want to execute a default function. So we're going to go std function void. That's not the right syntax, is it? Yeah, that's better. And we'll call this one default, and we'll initially set it to be an empty function that does nothing. So the default, by default, it does nothing, but we can maybe configure that with yeah, we'll do the same syntax here, like this, default, and return def. There you go. So now we've got a couple of functions to set up our cases and one to perform the switch. There's our string switch. This should maybe possibly work. So we would create a string switch like this, and we'll call it SW, and then we'll go SW.case foo is equal to some bullshit like this, and let's put another one in here, bar, and you did a bar, and let's go SW.default is equal to, I don't know, WTF. And then we can go switch on foo, switch on pubes, and we should get, you did a foo, and then WTF. What do we get? You did a foo and WTF. So there you go. You have now got your basic string switch. You got your cases set up, and then you can switch on them. The interesting thing about this is, unlike, you can do many things with this that you could not do with a normal switch. It's an object, you can pass it around to different functions and they can switch inside of themselves. One thing that a normal switch has is it can access variables outside of the switch, and you can do that here too. You can capture, so let me just show you here. We go int x is equal to 69, and you can capture something by value or by reference, and then you can use it inside of the case. You can also have switches that maybe take multiple parameters, and you could then your cases here wouldn't just be empty parameter lists. They could take parameters. They could also return values, which is something that you don't have with the normal switch. So there's a whole bunch of different possibilities that you could explore with this idea of a string switch. But this is the basic idea right here. To run this, we get the 69 now that we captured from outside here. So those are the main concepts that I wanted to teach in this video. There's actually a bunch of other stuff that I talked about, but I've cut it out. And it has to do with stuff like pointers to member functions and some more high-level stuff from the functional library, a little more complex stuff that you don't use that often. So because you don't use this stuff very often, you don't have to watch the video, but I'm going to take that footage and I'm going to put it in part 2 or a bonus video that comes after this one. So if you're interested in different kinds of function pointers, a little deeper dive into std functional, definitely take a look at that. I believe it'll be interesting. But if you're not that interested, then you can skip it if you want. Alright, it's time for the homework, and I have cooked up a doozy for you guys this time since it's the last homework of the intermediate series. So, what we're going to do is we're going to be creating a little bit of a simulation in Box 2D. Now, I've already done a lot of the hard work for you. I've got a project that you're going to start from, and you're going to build on that. But it's still going to be very hard, and one of the reasons why it's going to be hard is because I am going to drop you in the middle of this code. There's going to be no training wheels, no explanation. I give you this project, you have to orient yourself in the code and figure out what you need to do to accomplish the objectives. And some of you might feel like this is unfair homework, but think about it. This is a real scenario that programmers face in professional life every single day. So it's something that you're going to have to be able to deal with. And now that we're at this point of intermediate, I think it's time to face the music. So yes, this is going to be a hard task. It might take you a few days. It might take you a week even. But take time. Make the effort. You know, not all things in programming are convenient or easy. Some shit is hard and you just gotta fucking struggle through. One of the important things about this homework is the project is has dependency on Box 2D, and the dependency I made it via VC package. That's VC PKG. So you're going to have to be able to install VC package and use that to install Box 2D on your system. Now I've done a video tutorial on VC package, so you can look at that and that'll give you a starting point. But you're going to have to figure out the first task for this homework is you're going to clone the project and you're going to figure out how to get it to build using VC package. Once you're done that, your next task is going to be to have the simulation destroy boxes when two boxes of the same color hit each other. So you're going to have to implement some collision and event handling. The event handling, there's already some in there, so you can just have to look at that and figure it out. But I'll give you a hint. There is a pitfall when you're destroying bodies in Box 2D. So that's all I'm going to tell you. You're going to have to figure that out for yourself. So once you've got the general idea of event handling down, then you've got a choice to make. There's two tasks and you can take them in either order. The first task is I want you to create a pattern matching system using an unordered map. You'll see when you look at the code, but there are boxes and they have different color traits. There are 5 colors, red, green, white, yellow, blue, I believe. And what you want to do is you want to create a pattern matching system with an unordered map that will map different behaviors, different effects when boxes of different colors collide with each other. So a couple of examples of effects you might want to do are the destroy effect that we had up here, and maybe a color change effect where if two boxes hit each other, one of them or both of them change color. It doesn't really matter what effects you come up with, but the important thing is that you're going to do pattern matching with an unordered map based on the two different entities that collide with each other. So that's one, and this one is going to probably be very hard. Very hard in terms of coming up with the data structure and messing around. There's a couple of ways you can do it, but I'll leave that to you. And the second one here is box splitting. So when boxes collide with each other, you can make it so that they split. Or, well, you should make it so that they split. And to start off with, you can just, trigger it with a key press, split the first box in the container or whatever. Doesn't matter. But I want you to make it make an ability for boxes to split into 4. They should maintain their momentum and everything, but I'll show you an example of that in a second. And once you've got these two down, then you can combine them and create a system with the pattern matching where you've got a whole bunch of different effects depending on what boxes collide with each other. Destruction, color change, box splitting, anything else you want to think of. Let's take a look at what the finished product might look like. So let me just scoot this guy over here a little bit. All right, so I've made it so that when the blue and white boxes, when they collide with each other, they are going to split. I believe when blue hits yellow, yeah, here we go. You're gonna, you missed it. God damn it. So when blue hits yellow, it turns the yellow one blue. When blue and white hit, one of them will split. Now, if I can just okay, this looks like we're gonna get the money shot now. Here you go. So now you see that blue has split and now white is splitting. And once you get a few splits, then it's just a big chain reaction. It turns into a particle simulation. And it's pretty damn sweet if you look at it. The particles, they create a pressure, basically like a gas, and the big green one actually sinks to the bottom due to the pressure. It's interesting. It's a very interesting simulation. But anyways, this is what you're going to end up with. Now, it's not going to be easy. You're going to have to do a lot of your own research on Box2D, look at the documentation. But I think this is going to be a good homework. The code that I'm giving you to start off with here and that I will show you in the solution will give you a good idea of one way that you could integrate Box2D into a project effectively. So I think it's going to be a good lesson in and of its own. And if you get stuck at any point, just know that everything is going to be explained in the solution video. It's probably going to be a pretty long video as well. And I'm going to start with the background. So I'm going to explain the code that you start with, and then I will go through solving the different parts of the challenge. So if you get super stuck at any point, you can't figure out how the code works and you've banged your head against the wall for hours, you can always watch the solution video until the point where something makes sense, and then you can stop it and attempt the homework. Just a little suggestion there. But I do suggest that you don't just try it for a little bit and give up like a bitch, okay? I want you to really try hard to understand the code. It's not going to be easy. I didn't add comments. There's no hand holding here. You're going to have to read and understand some code. It's complex code. I've written it pretty idiomatically. It's not nasty C++ code in my opinion, but it's not dirt simple code either. And it's going to take work to wrap your head around. I suggest you use the debugger. I suggest you use the Google machine looking up stuff, specifically, Box2D stuff. But that's going to about do it for today. Hope you liked the video. If you did, please click the like button. It helps a lot. Good luck with the homework, and I will see you soon with some more C++.